everyone, and welcome to today's lesson. In today's lesson, we are going to talk about the subject physics, and our topic for today is work, energy, and power. We are going to talk about the definition of work, energy, and power, and their calculations concerning them and the differences between them. And by the end of this session, you should be able to answer questions based on this topic. Let us begin by defining what is work. Work or work done is said to be done when a force causes a body to move a distance in the direction of the force applied. Work is said to be done when a force causes a body to move a distance in the direction of the force applied. Its unit is in joules and it is a scalar quantity. If you haven't watched my previous videos on physical quantities, scalar and vector quantities, please do so. The link will be in comment below. Now, the formula for work done is force times displacement times cosine of theta. Force times displacement times the cosine of theta. Force is the force applied, displacement is the distance moved by the body, and theta is the angle of the force that the force was applied. Now we move on to energy. Energy is defined as the ability or the capacity to do work. There are two forms of energy. First, we'll look at potential energy. This is the energy possessed by a body by virtue of its position. Examples of potential energy include a stretched string. Potential energy or PE is calculated by mass times acceleration due to gravity times the height, mgh, or m times g times h, where m is the mass of the body and g is acceleration due to gravity and h is the height of the body from the ground. Now, we look into the other form of energy, kinetic energy. Kinetic energy is the energy possessed by a body in motion. Yes, for a body to possess kinetic energy, it must be in motion. Examples include moving car, a running horse. Now, kinetic energy is calculated using this formula. Kinetic energy is calculated using the formula half mv square. That is half times m times v square, where m is the mass of the body and v is the velocity of the body. Now, the velocity of the body, that is why it has kinetic energy. For a body to possess kinetic energy, it must be in motion. Kinetic energy and energy is a scalar quantity. If you haven't seen my video on scalar quantities and vector quantities, please do so to watch them, and I will leave the link in my comments below. Now, we move on to our next point in today's lesson. Power is the work done over time or the energy expanded over time. Power is the work done over time or the energy expanded over time. It is a scalar quantity and its unit is in watts. Now, let us talk about the formula for power, work done over time. So therefore, the formula for power is energy over time or work done over time. In the case of potential energy, it is mgh over time. And in the case of kinetic energy, it is 1/2 mv square over time. Power is also gotten from the formula work done over time. Force times displacement times cos theta over time. These are the formula for power. Now let us look at some examples or some questions concerning work, energy, and power. Now the question goes this way. Does a man lifting a bag do any work? Yes, the man does work because he lifts the bag from the floor above or to a higher level. It does work according to potential energy, mgh. Now let us look at another question. Now this question is, what is the velocity of a ball moving what is the energy of a ball moving with a velocity of 4 meters per second and weighing 0.4 kilogram? What is the energy of a ball moving with a velocity of 4 meters per second and weighing 0.4 kilogram? Now we will use the formula for kinetic energy because the ball is moving, because kinetic energy is the energy possessed by a body by virtue of its motion. Now, using our formula, kinetic energy is equals to half mv square. We have that the mass is 0.4 kilogram and the velocity is 4 meters per second square. Plugging all our values in the formula, we have that the kinetic energy is, plugging our values, we have that Ke is equals to half times 0.4 times 4 square, and half of 0.4 is 0.2. Therefore, Ke is 0.2 times 16. And finally, our answer Ke is equals to 3.2 joules. 3.2 joules. Now, let us look at another question. At what height must a body of mass 0.1 kilogram be to possess a kinetic energy of 40 joules? At what height must a body of mass 0.1 kilogram be to possess a kinetic energy of 40 joules? Now, obeying the first law of thermodynamics, which states that first law of thermodynamics states that energy can neither be created nor be destroyed, but changes from one form to another. So, kinetic energy of that body must be equal to its potential energy. That is, energy is interchangeable. It cannot be created or destroyed, but it changes from one form to another. Now, let us continue with our solving. So, from the first law of thermodynamics, we have a question. At what height must a body of mass 0.14 kilogram be to possess a kinetic energy of 40 joules? If the acceleration due to gravity is 9.8 meters per second square and the mass is 0.1 kilogram and the kinetic energy is 40 joules. Now, using kinetic energy is equals to potential energy. Therefore, 40 is equals to mass times acceleration due to gravity times the height. Now, we want to isolate the height. Therefore, using change of subject formula, which I will teach in mathematics, stay up next, stay tuned for mathematics change of subject formula. Now, height is isolated. Therefore, the height that the body must be is equals to 40 divided by mass times acceleration due to gravity, which is 40 divided by 0.1 times 9.8. And after plugging these values into my calculator, the height is 40.816 meters. 40.816 meters is the height the body must be to possess a kinetic energy of 40 joules and 0.1 kilogram of mass. Now we move on to questions pertaining for power. A boy climbs the stairs of 10 meters in 10 seconds. If he weighs 45 kilograms, what is the energy expended by the boy over time? Now, power is the energy expended over using G as 9.8 meters per second square. The acceleration due to gravity is 9.8 meters per second square. The mass of the ball is 45 kilograms. The height of the stairs is 10 meters. And the time it takes to climb the stairs is 10 seconds. Now, using the formula, energy over time to calculate the power, we have power is energy over time. Power is also M times G times H. So power is mgh over time. Now plugging all our values, we have that the power is, after plugging all our values, we have that the power is 45 times 9.8 times 10 over 10. Therefore, the final value for the power is 441 watts. Now let us look at one example before we call it a day. A boy pulls a truck with a force of 50 Newton at an angle 60 degree, alone on the ground 15 meter. Now he pulls the truck to a distance of 15 meter at an angle of 60 degree and with a force of 50 Newton. Calculate the work done. Now using the formula force times displacement times cos theta. Now plugging our values, we have that where the angle is 60 degree, the displacement is 15 meter and the force is 15 Newton. Therefore, work is 50 times 15 times cos 60. 50 times 15 times cos 60. Plugging all these values into my calculator, I have the value for the work is. Therefore, the work done is 370 joules. Therefore, the work done is 375 joules. Now, it is the do-it-yourself session. Find the kinetic energy possessed by a body of mass 50 kg and a velocity of 3 meters per second. A velocity of 3 meters per second. A velocity of 3 meters per second. Now, take acceleration due to gravity as 9.8. Hint: Ke, or the kinetic energy, is given by half mv square. Now do it yourself. If you like today's content, please like, subscribe and share. Turn on the notification bell so that you don't miss any of these contents. And watch out for my new videos. If you haven't watched derived and fundamental quantities, check it out in the link below. Thank you and good day.